Let's talk about rational functions. So what we have here examples of a rational function. And some of the things I want to show you are, one, they're usually broken up into two little graphs, as you can see here. And you can see this is 1 over x and this is x squared. Now the other thing that they have is asymptotes. This graph, for example, has a vertical asymptote. What asymptotes are, they has a vertical asymptote at x equals 0. What asymptotes do is they get very, very close to that line, the graph, but it never crosses it and it never touches it. Now, another asymptote that this graph has is a horizontal asymptote. And that's going to be at y equals 0. Again, the graphs get very, very close to this line, but it's never going to cross it, it's never going to touch it. And this graph has the same asymptotes here. Now, it doesn't mean that they're always at 0. They can move around, and that's what we're going to discuss in some of the sections, in some of the problems here. How to find it. So for a vertical asymptote, to find them, you're just going to solve the bottom equal to 0. To find a vertical asymptote, just solve the bottom of the fraction equal to 0. And now, how to find horizontal asymptotes. I did put some steps on the written notes. To find a horizontal asymptote, you're going to locate the highest exponent of x. So if it's on top, you don't have a horizontal asymptote. If it's on the bottom, the horizontal asymptote is y equals 0. If they both have it, it will be the leading coefficient on top divided by the leading coefficient on the bottom. And I'll show you as we work through some examples. Use the graphs of the rational functions in these choices to answer each question. There may be more than one correct answer. Which of these ones has a domain between negative infinity and 3, and then from 3 to infinity? So we're looking at who has an asymptote at 3. So that would be A. You can see here that it's broken up at x equals 3. So it's this one. And so it's letter C. This one is open at 3. But it also has an asymptote at 0. So the domain is actually between negative infinity and 0, and then 0 and 3, and then 3 and infinity. So the domain for that one is different. The domain for this one, and then from 0 to 3, and then from 3 to infinity. So that doesn't qualify here. Which one has a range with 3? So it has to have a broken line at 3. So that would be letter B. Which one has a range of 0? So you need to have them broken up at 0. So I know it's A for sure. What happens with this bottom ones is they don't have anything on negative infinity. So the range for this one would be from 0 to infinity only. So that qualifies over here, C and D. Now, which of these does not have a vertical asymptote? So I did say to solve the vertical asymptotes, you solve it the bottom equal to 0. So you're gonna get all of these bottom ones and solve for x. And what happens is you're gonna get solutions. Like here, you would get plus minus the square root of 2. Here, you're gonna get 0. Here you get 8. When you solve this one, you're going to get plus minus the square root of 2i. So when you get imaginaries, they don't count. So then this one has no vertical asymptotes because imaginary answers do not count. Identify any vertical, horizontal, or oblique asymptotes for the graph. So like on this one, I'm gonna call VA for vertical and HO for horizontal. The vertical asymptote is this one, so it would be at x equals, they're in twos, x equals 2. And the horizontal are y equals 4. That would be that one. Here, the vertical asymptote would be at 4, -4, and the horizontal asymptote would be at y equals -2. This is how. This one has a vertical asymptote at x equals -1. No horizontal. The oblique, they're called oblique because see that's crooked. So that's the oblique right there. This one is going up and it has a slope of 1. So it will be y equals x minus 1. So to do the, I figure out it's going up, so the slope is positive. And then I create a triangle between 2 points. And you see it's 1 and 1, so it's 1 over 1. So my slope is 1. And then the y-intercept, because remember it's like this. You need the slope and you need the y-intercept. So that's how I find the slope, and the y-intercept is at -1. So that's how I ended up finding that one. And then some examples from my open math. Here is a function, and then they want us to find the following things. Now for functions like this, sometimes the best thing is just to try to factor the graph first. So let's do that. If you're going to use your calculator for the factoring, you would do it the following way. Here's my calculator. I'm going to go to mode, click 5 and 3. And then what you're going to do is you're going to put, like in the quadratic, A, B, and C. So if I put A, it would be 3, B would be 1, and C would be -10. So you get 5 over 3. I went over a lot of the details on how to do this with the calculator on the review for the lab. So if you haven't gone over the lab first, 1.6 in the lab, you need to go over that first and then come back to 1.6 to this. But we did a lot of this in that section, so I'm not gonna go a lot in detail because we went over it on that other section already. So it's 5 over 3, and then the other one, -2. So it's gonna be 3x minus 5 and x plus 2. Now I'm gonna do it in the bottom. 2, -3, 1. I get 1 and 1/2. So it would be x minus 1, 2x minus 1. You always have to do this first just to make sure that nothing cancels. And in this case, that nothing cancels, but it also makes the problem a little easier to solve. And I'll show you why in a little bit. So the y-intercept. The y-intercept is just putting 0 for the x's. So we're just going to get the problem and put 0 for every x. I'm getting the original problem because nothing canceled when I did the factoring. So the y-intercept is 0, -10. 0 for the x. The x-intercepts are the points from the quadratic, but just on the top. And we did it up there, so we know it's 5/3 and -2. So the x-intercepts would be 5/3, -2. The vertical asymptotes are going to come from the bottom. So I'm just going to get the answers that I got from the bottom. So like we got, the bottom was 2x squared minus 3x plus 1 equals 0. And we got x equals 1. These are your asymptotes, those answers that you got from the bottom. So see, even though nothing canceled when we factored, we kind of already did a lot of the solving of the problems because we had already solved the top and bottom separately. For each of the functions, determine the following. For that function, the horizontal asymptote. So for the horizontal asymptote, you're going to look for the highest power of x. And in this case, it's on the top. So if it's on the top, you don't have a horizontal asymptote. This one, the highest power, is on the bottom. So when that's the case, it's this one. This one would be both. So what you're going to do is you're going to get the numbers right next to them and divide them. So it would be y equals 1. That's how the horizontal asymptotes work. Those are the two options you always get, either top, bottom. So this is a perfect example on the rule for finding the horizontal asymptotes and an example of each. So this is a really good page, if I do say so myself. Okay, let's do one more example. Let me see. This is very similar to the one we just finished. Not the previous one, but the one before that. So I'm going to do this one. I think there's two more examples here. I do welcome you to do them and then check the answers with the actual notes that I posted. But I'm going to do one more with you so that you can see how I'm getting all the answers, and then we'll move on. But if you feel confident that you already know them, feel free to just fast forward and work on them on your own and then come back, or fast forward to the next thing. Okay, so I'm going to do the factoring first, and for that I'm using the calculator to help me. Remember, it's mode 5 and 3, and then you're putting A, B, and C. So I'm going to put 2, -3, -2. I get 2 and -1/2. And I'm going to put them here because that's going to help me to know if I'm missing anything. So then, if it was factored, it would be x minus 2, 2x plus 1. Then I'm going to do the bottom because remember, we do need those answers, not just the factor, but sometimes the answers. So that's why I want to be careful there. Now on the bottom, it will be 3, negative 13, negative 10. Oh, this is one where I think the notes are off because I think I used a different number. So we get 5. So this may be, your notes may be wrong on this one. So you may want to keep track of this or copy this again. And then negative 2/3. So if I was going to factor them, it would be x minus 5, 3x plus 2. We still nothing cancels, making me a little uncomfortable, that one. Nothing cancels, so we'll keep it like that, but we know it's useful for later things on the question, so I don't feel bad that I did it. So the y-intercepts, again, you're putting 0 for every x. So I get negative 2 over negative 10, which is 1/5. So my y-intercept is 0, 1/5. The x-intercepts come from the top, so they come from solving 2x to the third squared minus 3x minus 2 equals 0, and we already have the answers from the factoring that we did. So I know that these are going to be the answers. And again, I cannot say this enough. I think the notes are wrong on these, so you want to fix them either on the side or copy them again, because I think I made a mistake on the actual notes when I was doing the factoring. The vertical asymptotes are going to come from the bottom. And again, we have the answers for these already. They're going to be 5 and negative 2/3. So those are going to be the answers. Now for the horizontal, you have to see where the highest power of x is. And in this case, it would be with both. So it would be y equals, what I'm going to do is I'm going to get the numbers right next to them. So it's 2 divided by 3. And that's the horizontal asymptote for that. This one is very similar. So I will let you work on it on your own, and you do have the solutions for it on the notes page. Now let's go to some of the graphs here. Draw the graph for the following by placing the horizontal and vertical asymptotes and then placing additional points. So let's start with the vertical asymptotes for these. It's the bottom of the fraction, and you set it equal to 0, and you solve for it. So x equals to 1. So when I go here, it will be x equals to 1. Now the horizontal asymptote, the highest power is on both, so it would be y equals 2 divided by negative 2, which is negative 1. So it would be this one here. And then my open math is going to require for you to plot additional points, and it would have to be 2 points on each side. So I'm going to do 2 and 4 here on this right side. Maybe 0 and -2 on this other side. Now you are going to plug them in into the original fraction to get your point. So for example, I'm going to put the 2, it will be 2 plus 4 divided by -2, like that. And now you can always set it up in the calculator if you feel like fractions are too scary. Set up the fraction and then do 2 times 2. The good thing about setting up in the calculator also is that then you can just change the inside of the parentheses. So you get -4. So it'll be 2, -4. And then if I'm going to test 4, since I already have it in the calculator, I'm just going to change the parentheses to 4s. And I get -2, so that's 4, -2. And then 0 and 0. So I get 2. So you see, even though I set it up once, then I just change the parentheses to the number I need. And that gives me the answers. Now on my open math, like I said, you're going to have to plot 2 points on each side, so you can do that in my open math will graph it for you. So this one would be 0, -2, 0, 0, 2. And then my open math will do that. And then on this side, you're going to do 2, -4, and 4, -2. And then it will get it done for you. So you start by placing the vertical and horizontal asymptotes on the graph, and then you plot the extra points. So that's going to be very similar to this one. Now let's write some equations. Here's some information. Write the following function. It has vertical asymptotes at those points. It has x-intercepts, and that's the y-intercept. Well, the vertical asymptotes give you the bottom. The x-intercepts give you the top. Now you have to make them into functions, so you're going to switch the sign. So it would be x minus 4, x plus 4, and then this one would be x plus 2, x plus 6. Now, how do we use, so what you have here, the tentative solution, or what we have so far is, there may be some factor that cancels out that we don't know about, but on top I have this, and then on the bottom I have this. Now we're going to use the y-intercept to find a. So the y-intercept would mean that x is 0 and the y is 4. So I'm going to put 4 equals a, and we're using it to find that a for our answer. So to solve for it, I'm going to do the reciprocal. So a equals -16 over 3. So when you write the answer, it's the whole function. You're going to write y equals -16 over 3. And then on top, and then on the bottom, So this is the whole answer. Now let me erase this so that we can work on the next one. Either way, like I say, you already have all of those worked out on the worked out notes that I posted. Okay. The vertical gives us the bottom, so the bottom will be x minus 1, x minus 6. The x-intercepts gives us the top, and the nice thing is when they give you the horizontal asymptotes, this gives you a. So in a problem like this, it's already everything is done. You just need to write it in. Oops, I put 6 instead of 1, so it just doesn't matter the order in which you put them as long as you put both parentheses. So, like that. When they give you the y-intercept is when you have to do the little work. When they give you the horizontal asymptote, you're done. They give it to you right away. Now write the equation from the graph. Okay, so let's locate the asymptotes. Basically, we're gonna locate the information they gave us on the other problems here first, and then we write the equation. So, let's see. Give myself some space here. And let's see the vertical asymptotes, because that's gonna give us the bottom. Where x equals -2, this one, and this one. Where x equals 4. The x-intercepts, because those are gonna give us the top. So you're looking, this is the x-axis. So it's this one. That's it. And the y-intercept, because that's going to help us find a. Okay. So then it will be y equals a. The top is just x minus 2. That comes from the x-intercepts. And then from the bottom, it would be x minus 4. Now to find a, we're going to use this. The x is 0 and the y is 1. So I'm plugging in it. Is going to equal 4. So my answer will be 4x minus 2. Okay, so let's work on this one. Again, we're going to try to find that information first. So let's start with the vertical asymptote. And that would be at x equals -1. And then x equals 3. One thing to notice here is notice how, let's go to this one. You have the vertical and then you have the graphs on opposite sides. You see? Now when the graph on opposite sides. Now on this one, the graphs are both on the same quadrant. So when that happens, this has a multiplicity of 2. It's an even multiplicity. And I'll show you how that plays when we write the answer in a little bit. Now let's do the x-intercept. And that, we know that it's a multiplicity of 2 because here's the asymptote and both lines are on the same side. Okay, now the x-intercept, x equals 2. The y-intercept, 0 for x, -2 for y, right there. Okay, so the setup will be a, on top you have x minus 2, and on the bottom you're going to have x plus 1, x minus 3 squared. That's how the multiplicity plays a role, because that's going to be to the second power. Now to find a, so to find a, we're going to put the y-intercept, this one. So that will be -2, and then 0 for every x. So what that's going to give us is -2 on top and a 9 on the bottom because of that square. And we're going to flip the fraction so that we can bring it over here. And we get a equals to 9. So the final answer would be, you can put the 9 here in the front or you can put it on top if you want. Like that. Now, there's more examples on the notes, but all of them kind of come back to what we just did here. So, as you're working on the problem, if you have questions on the notes, on any of the problems I did, you know the drill. Any questions you have, don't hesitate to contact me either on the ones I just covered, the ones on your homework, the ones that you see after, any questions you have. Always let me know and I can always do extra examples for you.